Welcome to Mathy Python. This is the Beginning Python series, episode 10 on functions. So far, every piece of logic we have written has lived in line directly in the code where we needed it. Today we look at how to package up a piece of logic, give it a name, and call on it whenever we need it. This is called a function. Once it is written, you do not need to remember how it works internally. You just need to know its name and what to give it. This is one of the most important ideas in programming. Once you have functions, you can build things that would otherwise be unmanageable. Let's write a function that computes the area of a circle. So def means I'm defining the function. Then I give it a name, circle area. I need the radius. The area is equal to 3.14159, let's say, times radius squared. Again, double star, not a caret. And once I've calculated the area, I need to return it to whatever called this function. So functions typically they have def in Python that says that you're defining a function, the name, whatever parameters you have, then it processes, it does something. Doesn't have to, but typically it will return some value. So now I can say, what is the area of a circle with radius 7? There it is. What's the area of a circle with radius 3? What's the circle with area of 10? Okay, so I can give it any values that I want. So the parameter is radius. The specific value of radius that I'm feeding in is called the argument. So we have circle area of 7. That means radius is 7. The area is 3.14159 times 7 squared. And it returns that, which then is output. So it's the same logic, but a different input. Which is the entire point of a function. You write it once, you use it as many times as you need with whatever value that you get it. I could store this return value in a variable. So I say that A is the variable with the value of whatever a circle is with area 7, and then I can print that out. I could say, let's say the total is equal to circle area of 7 plus circle area of a circle with radius 3, and then we'll print that out. So I could say the combined area equals, and then the variable whose value I am printing out as total. And let's print out 2 decimal points for this float. Okay, so the combined area is 182.21. Okay, let's talk about the concept of encapsulation. There's a word for what just happened with circle area that's worth knowing. That's encapsulation. So encapsulation means hiding the internal details of how something works behind a name. So the rest of your program only needs to know what the function does, not how it does it. So when I call circle area from somewhere else in the program, I don't have to know the formula that makes that work. At that level, I don't really care. I just want the area of a circle, and I let the function take care of all the details. So the logic is sealed off inside of the function. The only thing exposed to the outside is the name, plus whatever it expects as input and what it gets back as output. This matters for a couple of practical reasons. First, it reduces how much you need to keep in your head. Reading code that calls circle area radius 50 lines later, you do not need to rederive the formula. You trust the name and you move on. Second of all, it isolates change. So suppose later we decide to compute area more precisely using math.py instead of the value I gave it. So I will copy that, paste it here. I will import math. And now I can call math.py. So this is a more precise way of calculating the circle area. I can just use the math module for the value of pi. And so here I've made a change to the function, and it will just trickle out through the rest of my program. So if I'm writing a large program with hundreds of lines that calculates lots of circle areas, I don't have to redefine the formula for each of those calls. I just do it once. So keep encapsulation in mind as we go. It is the instinct behind writing small, well-named, self-contained pieces of logic, and it comes up over and over constantly as programs get bigger. Let's look at some more examples. A function doesn't have to involve math, of course. It's not just formulas. So here is one that builds a greeting. I'll call it greet and have a name. And it will return the F string. It doesn't print it here, it just returns the string. And it will say hello, value of name. Welcome to Mathy Python. Greet Mark. So Mark is the value of name. And it says hello, Mark, value of name. Welcome to Mathy Python. Greet Zaphod. Now the argument Zaphod is the value of the parameter name. So it says, hello, Zaphod, welcome to Mathy Python. Let's make a function that does a small decision inside of it using the if logic. So we have def classify temp, have our temperature in Fahrenheit. Let's say if temp F is less than equal 32, return freezing. Else if temp F is less than 70, we return mild. Else we will return warm. Okay. So now we classify temp 20. I do have to actually run that cell to put it in memory. And spell it correctly. There we go. Classify temp 20. The value of temp F is 20. If 20 is less than equal 32, it is, so it returns freezing. Freezing gets returned to the cell, and then its output. Classify temp 55. That's mild. Classify temp 90, and that is warm. Functions can contain any kind of Python, conditionals, loops, calculations, whatever. The function is just a wrapper that gives you a name, that gives a name to a piece of logic and lets you run it whenever you need it. Two words worth being precise about, since you'll see them constantly in documentation and error messages, and it's a way to talk about it with your colleagues. So in the function definition, radius and name and temp f are called parameters. So going back to circle area, the radius is a parameter. They're placeholders defined as part of the function itself. Then when you actually call the function, the value you pass in is called an argument. So here 7 is the argument. Right, so here radius is a parameter, and then 7 is an argument, which is the value of a parameter. In this case, the value of radius. The parameter is the name in the definition. Argument is the actual value you supply when you call it. People often use the words loosely and interchangeably in conversation. Technically, that's not right. The definitions are worth knowing, since you'll see it in error messages and in the documentation. Sometimes a function will just print something. It doesn't return a value. So I might have a function called add and print AB. And it will print A plus B. Let's make another one. Add and return A, B. And here we returned A plus B. Okay, so if I add and print 5 and 3, it prints out 8. If I want the value of two numbers added, I would say add and return 5 and 3. So that returns the value 8 to x, which I can now inspect. So x is equal to 8. So print just displays something. Return hands the value back to whatever called the function, so you can store it, pass it along, or do more math with it. We've been using return so far for exactly that reason. From here on, prefer return when you want to actually do something with the result afterwards. Let's talk about default arguments. So parameters can have default values used automatically when the caller doesn't supply one. What do I mean by that? Def, let's say power base exponent by default will be 2. And then we'll return base to the power of exponent. If I say power of 5, 2, I'm calling the function power. My base is 5. My exponent is 2 because I told it. And then it returns 5 to the power of 2, which is 25. If I say power 5 and I leave off the 2, still gives me 25 because it's passed 5 in as the value of the parameter base. The exponent, I didn't say what the exponent is, so it takes this default value of 2, returns 5 to the second power, 5 squared, which is 25. I also ask 5 to the third power. 5 times 5 is 25, times 5 is 125. So that works out. Let's make a function that computes compound interest on some principal, the money you feed it to begin with, whatever the rate is, and however many years you let it compound, and then we'll return principal times 1 plus rate to the power of years. That's just a formula. Then we can look at compound interest. Put in $1,000, 5%, APR, annual percent rate. Leave for 10 years. Okay, and we get 1,628 and some change. By position, arguments fill parameters in order. So how do I know which of these values gets mapped to principal, which one is a rate, and which one is years? Well, it's just an order. So principal is first. So the first argument is 1,000 is the value of principal. 5% is the rate because that comes second. And then 10 is the number of years because that's third. Well, let's say I'm programming along and I've forgotten the positions of things. So I could just spell it out. Years is 10. The principal is 1,000, and the rate is 5%. Okay, I get the same answer as I did before. And how does Python know which order to take these in, or which parameters should be given which argument? Well, it's spelled out here. So the years parameter takes the value of 10, principal takes 1,000, rate takes 5%. Then it calculates this and returns it. Once you start mixing positional and keyword arguments, these are called keyword arguments because the arguments are given by the keywords or the parameters. Another good reason to do this is to make it explicit what you're doing, that the years is 10, principal is 1,000, rate is 5%. You can also mix positional and keyword arguments. So I could say the principal, is 1,000 because it's first. Then say years equals 10, rate equals 5%. So the first argument I gave was in order, so it gets mapped to principal. And then years is 10 because I said, and then the rate is 0.055%. If I do keyword arguments first, Python will get confused. It doesn't know what you mean by this. So the rate, the years are 10. That takes care of this one. Rate is 5%. That takes care of this one. There's only one left. That's not true in general, but in this case, there's only one left, but Python's not going to chase that down for you. Okay, functions calling other functions. Functions can call other functions. This is how you build complexity out of simple pieces. So maybe I have Celsius to Fahrenheit, and I feed it in temperature in Celsius, and I return C times 9/5 plus 32. And I have another function called describe temp, and I pass it in a value in Celsius. Then Fahrenheit equals Celsius to Fahrenheit of the C that you passed in. And then we'll say if F is less than equal 32, we'll return the string that says that temperature to 1 decimal point degrees F is freezing. I'll go ahead and use the else if we saw. You could also use an F in this case. F less than 70. Let's say this is cool. Else that is warm. Okay, now let's describe 20. Describe temp. So 68 degrees is cool. Let's try it with 21. 69.8 degrees is cool. Describe temp does not need to know how Celsius to Fahrenheit does its job. It just passes a value, it gets one back, and it's done. So that's encapsulation again. This time it's one function relying on another's name and contract rather than its internal logic. Variables defined inside a function only exist inside that function. This is called scope. So for instance, let's add one to x, and the result is x plus 1. Then I'll return the result. Let's add 1 to 5. So I get 6. Let's print the result. Result is not defined. Why? Result only exists within this function. So when I add 1 to 5, x equals 5. Result is 5 plus 1 is 6. It returns 6 to this function. When I try to print the result, this result, variable name result, is not inside of that function. It does not peek inside of the function pull out result and then print it for you. So why is it set up this way? Well, if you have lots of functions, you'll probably have result. The variable result shows up on many of those. So you don't want those different results to get confused, or the different x's to get confused. So it only exists within the function, and that keeps it from colliding with variable names inside of some other function. Okay. Let's look at this stuff. Define a function. I'll call it does not change outer x. And it defines an x internally, which is 20. And then let's print that x. Here we use some code. X equals 10. Does not change x. Oops. Does not change outer x. And then print x. So the question is, what's going to get printed here? So x in the outer scope is equal to 10. Then it calls this function does not change outer x. Within the function does not change outer x, you see x equals 20. This is a different variable. This x is created within the function, and then it's printed. So this will print 20. Then we print x. So what is the x that gets printed? Is it the outer scope or is it the inner scope? Well, we're not inside of the function does not change outer x. We're not in there. So this x has come and gone. It's irrelevant to the x down here. So in the outer scope, this x is going to be 10. And in fact, it is what it does. X is 10. I call the function. It prints its internal um, copy of X, which is 20. Then I jump out of that function, print X. It doesn't care what's in the function anymore, and it will print 10. So how does Python actually keep track of all this? It does it with namespaces. So the same idea from episode 3, but now we have multiple namespaces. So the namespace was just a table of variables and their values and their types. And so there is a namespace for the outer scope here. And then each function has a namespace, a table of variables and values internal to it. And a namespace for the function only exists within the function. Functions let you package logic, give it a name, and reuse it. Encapsulation, parameters and arguments, return versus print, default and keyword arguments, functions calling functions, and scope. That's what we covered. And that's how you start writing programs instead of these little baby scripts that we've been writing. In the next episode, we'll work with files, which is reading and writing data to or from disk. The link for the notebook on my GitHub page is in the description. I hope you enjoyed the video. If you like it, then please subscribe. Thanks for watching and happy programming.